guys. Our last topic today is welding consumable. All right. All right. Welding consumable are any product that are used in production of weld, like cover electrode, filler wire, shading, or OC fuel gas. This is what normally shading gas we use in TIG, Big Mac, or even in flask also. Separately supply flux, like what we use in SAW. Fusible insert is what we use in TIG. Yeah. Right. So those are the standards for MMA, MIG-MAG, TIG, SAW, and those are consumable like solid wire, core wire, rods. Yeah. And for welding gas, normally we use in G-mount, flask core, thick, oxy fuel, and color-coded cylinder to minimize wrong use, like we have green color and blue color, or argon, or mixed with helium or something. All right. So each welding consumable is critical in respect to size, classification of supplier, like, we have supplier like Kobe, Lincoln, ISAB. Condition, is it required treatment? Like basic electrode in MMA, yeah? Required baking. Handling and storage critical for consumable. Handling and storage for gases is critical for safety. All right, so for assurance, quality assurance, filler material must be stored in area with controlled temperature and humidity. Poor handling and incorrect stacking may damage coating. For example, storekeepers stack too high. The problems there at the bottom of the box electrode may be because of the weight. It will damage the flux. Yeah? Control system for electrode treatment must be checked and calibrated. Those operations must be recorded. So if we have like MMA using basic electrode, there is oven. So oven must be calibrated. And we inspector also must check the logbook, how many kilos given to welder A, how many kilos basic electrode written back. Yeah. So in MMA electrode, we always got three types of electrode here: cellulose, rutile, and basic. So for the normal basic electrode, normally supply in cardboard and also in rutile electrode. Cellulose normally in tin can. And vacuum seal pack here, still a basic electrode. This is still basic electrode, but special seal. So this, when the welder open it, or before the welder open it, they're going to use it. So we must write down date and time, right? Here, because this only can be used in 4 hours. And not require baking because it's already sealed, right? This type of basic electrode already sealed, and not require baking. Yeah. Normal electrode like this, basic electrode, before use, we must bake. Yeah, before use. All right. I would like you to highlight a few things here. The first thing we're talking about cellulose. Please highlight the level of hydrogen here. Please highlight this level of hydrogen. We got between 80 to 90 milliliter of hydrogen. So what's the problem? What's the advantage having very high hydrogen in cellulose? Say here, if we have high hydrogen, it will rise in the arc voltage, meaning it's giving more heat or increasing heat, yeah, from having this hydrogen. So when we got more heat, then able to have more penetration or fusion, and able to weld at high speed without risk of lack of fusion. Okay? So that's why in old days when they're doing welding in pipeline, right? Like here, stovepipe here is referring to pipeline. Using cellulose, normally they use with PG position, which is vertical down. So high speed we can achieve by having PG position. But the good things, because of it more heat, then high speed without lack of fusion, right? Can we weld without lack of fusion? PG position is vertical down, it's very high, very speed, yeah? So there is no problem with lack of fusion. That's a good thing about having high hydrogen in the electrode. But the problems here is the hydrogen cracking. Remember, hydrogen crack occur when it's more than level of hydrogen more than 15 milliliter per 100 gram. Yeah. So in cellulose we have 80 to 90 milliliter per 100 gram. So form thin slate layer with a coarse wear profile and not required baking. Look at here. Because when you bake, you will reduce the amount of hydrogen. So that's why here not required baking, because if you bake this type of electrode, you will damage the electrode covering. And it will lose all the good thing having a high hydrogen here. Yeah. All right, now we look at rutile. The hydrogen content in rutile at in the last statement here, between 25 to 30, which is still high hydrogen, but lower than cellulose. Right, highlight this one. Easy to strike are excellent for position welding, meaning this type of electrode, we have the welder has no difficulties in order to weld all positions, right? PA, PB, PC, PD. So that's why I said here, excellent for position welding. Stable to use, can operate both DC, AC, slightly easy to detach, smoke profile, reasonable good strength, only used on general purpose work. It's not for high strength or high pressure material, right? Like a low pressure pipe work, support bracket. Electrode can be dry only, not bake, cannot bake. Dry, yes, in order to lower a bit the hydrogen content. Cannot be baked, same like in cellulose, cannot bake. If you bake, you damage the electrode, right? And this one, they call it high recovery rutile electrode. What does it mean by high recovery? High recovery here means it's got additional iron powder in flux. Additional iron powder in flux. Okay. So what's the good thing about having this iron powder in flux? It said it will increase the volumes of the weld up to 180% compared to normal electrode, right? If we have normal electrode, maybe the volumes of weld up to 80% from single electrode. By using this high recovery iron powder, it will increase double, right? Up to 180%. All right, please memorize a bit about this, yeah? About high recovery rutile. Yeah. All right, basic. All right, if you look at basic, it says produce convert wear profile and difficult to detect, like very suitable for high pressure work, thick section and high strength steel. So that's the good thing about having this basic electrode. Prior to use, electrode should be baked 350 degrees for 2 hours plus to reduce moisture to very low level and achieve low hydrogen potential status. So only this type of electrode must be baked. Yeah? Not for cellulose, not for rutile. And then if we look at in the level of hydrogen, after bake, this one 5 milliliter, we got after electrode bake. After bake, then we have 5 milliliter. Before bake, the hydrogen level is still high. Yeah. Right. So in this one, the most important for you guys to memorize a bit from this designation number or letters here is B346 here. All right. All right, guys. Remember, you only need to the question possible asks you about what is it 46? What is it number 3 here? Let me increase. Let me zoom. Okay. All right, guys, what you need to memorize a bit about what does it mean by 46, what does it mean by number 3, and also B stand for what, all right. If you look at here, in, let's say that 46 here, the number 46 here, that's referred to symbol 46 in yeast strength, you put another 0 there, which is 460 Newton millimeter square minimum. Remember this, minimum in yield. Clear about this? If the number changed to 50, meaning it's 500 Newton millimeter yeast strength. Right? Clear about this? What is it number 3 stand for? All right, number 3 here is the toughness value, meaning they carried out Chapi at minus 30, but still achieve, this is minimum, 47 joule. Clear about this? So that things you need to memorize a bit. If they put number 6, meaning they test Chapi at minus 60 degree, but still achieve minimum 47 joule. All right, clear about this? Okay. And the rest, don't worry too much. But this one, if they put B, meaning it's a basic electrode. All right. Other things like RR here is a rutile recovery. Right? That's the thing you need to memorize. Yeah. RR means rutile recovery, iron powder electrode, but rutile type. Yeah. Okay. So we're back to this. We're back to your slide. Okay. Remember. All right. 46. Number 3 here and B. So that is possible they ask you. Okay. So in European, that's easy to recognize type of electrode because when it put C means it's cellulose, when it put R means it's rutile, and please memorize a bit about this. Double R meaning it's rutile recovery. Okay. And we have basic, which is B. And in AWS, 01 is stand for the last number here, 0 or 1, cellulose, 2, 3, normal rutile, but number 4 here is rutile recovery. Okay, 5, 6, 8, that for basic. All right, I would like you to memorize this thing. All right, yeah, memorize a bit. Okay. Cellulose, used straight from box, not require baking or drying. Rutile, no baking, but you may dry at 120 degrees. Okay, that's the thing you need to memorize a bit. And then we have vacuum pack. You can use straight from manufacturer because it's already sealed. All right, basic electrode must be baked in oven for 2 hours at temperature 350. Then after baking, put in maintain oven, or they call it holding oven. Remember, this one roughly about 300, holding oven about half, and then the welder bring cuber and another half temperature. This must be used only for 4 hours in cuber. If not finished, then must be rebaked. Okay. So what to check in electrode? So you must check the diameter, the length, check if there is any crack chips, and also check the concentricity, and also check the designation number of the electrode. Okay. Now we look at in TIG, welding consumable for TIG. Normally we use filler wire, sheathing gas, tungsten, considered as a non-consumable. Filler wire of different material composition, variable diameter, variable and standard length with applicable code stamp for identification. Steel filler wire of high quality with copper coating to resist corrosion. So this is for apply for steel wire. Steel wire must be copper coated to avoid corrosion, but that not apply to stainless steel wire. Stainless steel wire never copper coated because there is no problem with the corrosion. Okay? So this is what in they supply cardboard or plastic tubes. And this one, fusible insert, basically they apply for the root. And this become a part of the joint, permanently become part of the joint. So that they call it fusible insert in TIG. So they will place in the root like a ring, for example, pipe, and then they will weld with TIG, and fusion occur and become a part of the joint. Yeah, it's not kind of like a removable baking, or it's not that type of things. Yeah. All right, sheathing gas. Don't worry too much about this. If you have time, you may read through. And then we have helium. All right, and then we have the hydrogen. That's sheathing gas in TIG, but hydrogen is not a main gas. Here they say they're up to 5% only. The main gas in TIG, helium and argon. Yeah. All right. So other than that, like hydrogen is not a main gas. Only small percentage added during welding of TIG, and also goes to nitrogen. Nitrogen is not a main gas. It's only used up to 5%. Yeah. All right, MIG-MEC. So welding consumable for MIG-MEC, spool of continuous electrode wire and sheathing gas. So it got spool of wire, continuous wire can be produced during welding. Variable size up to 1 to 15 kilo the weight, and wire diameter can be 0.6 to 1.6 mm. And here it says some electrode wires copper coating, purpose corrosion resistant, and gases used can be 100% CO2 or maybe CO2 plus argon. So we have here plastic spool, wire spool, and coil. And again, for carbon wire, it must be copper coated. That's applied for carbon steel wire. So this is what we see with this. So this is stainless steel, so not require any copper coating. All right, this one, they're talking about how to check the wire. Careful a bit about this. So they have two types. They call it cast diameter, and another one they call it helix size. So the simplest way to check the quality of wire in MIG-MEC, when you press the nozzle, if the wire produces very long loop, very big loop, that's a good wire. But if you press the nozzle, the wire goes like this, very small loop, then you have problem with the quality of wire. Maybe the roller, when they pull the wire, is very tight. So that's why it starts to spin the wire. When it spins the wire, then possibly it will produce like this. It will affect the contact tips. The purpose of contact tip is to hold the wire and transfer the current. But gradually, it starts to lose, right? Wear off, loose. So not enough current supply. Yeah. So careful be about this. Maybe they ask you about the checking of the MIG-MEC. Yeah. All right, so don't worry too much about this sheathing gas. If you have time, you read through. All right, and also this one. Okay, if you have time, go and have read through of this. All right, this one for flux core wire, they have flux inside the wire. Yeah, so that apply for flux core wire. So it has three types. Seamless, this is very high quality. because it's not sensitive to moisture pickup. There is no way moisture can enter the flux inside. It's a medium quality in the butt joint. It's a good resistant to moisture. This is medium quality. And the worst quality here is the overlapping, because easy to get moisture trapped inside the flux. So that's why this one overlapping core wire is considered as a low quality wire. Yeah, that's for flux core. All right, SAW, what we have here is the wire can be supplied in coil, reel, or drum, random for line winding. So in coil, approximately up to 25 kilo, reel 300, and drum up to 450 kilo. Yeah. So used for carbon steel, low alloy steel, creep, stainless, nickel, special alloy, can be solid wire or metal core wire. So again, for the carbon steel wire, like a mid-mag, always copper coated. Yeah. What's the functions of copper coating? It said to assure good electric contact between wire and contact tips, to assure smooth fit wire through the guide tube, to provide protection against corrosion. All right, welding flux in SAW are granular mineral compound mixed according to various formulations, sheet the molten weld pool, shield the molten weld pool from the atmosphere, clean the molten weld pool, can modify chemical composition, prevent rapid escape of heat, can be fused. So there is two types of flux in SAW, fused or agglomerated, or maybe they can mix both of these, and must kept warm to avoid porosity. Okay. So this is an example of the SAW welding flux. So here, fused flux here is said not hygroscopic. Hygroscopic here is a water base. So not hygroscopic means it's not water based. And this type of fused flux is a low quality. Right? This is low quality flux. But when it comes to agglomerated, this is what they call hygroscopic. Hygroscopic means water-based. Fused, not hygroscopic. But agglomerated, high quality. So for high quality here, that's what they mentioned, agglomerated flux can be recycled with new flux. Eh? But the problems here in agglomerated, flux too fine, dust, it start to break to dust, then it will pack if not fit properly. And similar treatment as basic electrode mean before use we must bake. Yeah? Bake before use. Fuse, no need. Only warm. Yeah? All right, what is it ceramic baking in SAW we use for? Basically, ceramic baking we use in order to avoid burn through during welding. That's the only purpose. So they place at the root area, and then they can increase current and then start welding. All right. So don't worry about this. Welding consumable inspection and validation, they will not ask you about this. Okay. If you have time, you may read through, but they're not asking you in exam. Okay. All right, you are currently employed as senior welding inspector in fabrication yard. The yard has numerous major oil and gas projects under construction. Part of your duty to monitor the control, storage, handling of welding consumables used during construction. All right, look at question 1. One of your inspector informed you that batch E8018 allowed to arrive. You may not refer to spec, but also you may check from the spec. Yeah, because the answer here, you may look at from the spec, but basically it's not really, if you look at the question, read carefully, basically it's not required any spec, but you may check from the spec for better understanding in order to answer the questions. Number 2, this is very clear. They're talking about spec, then you refer to spec. 3, this one is no spec because they only ask you what purpose of copper coating. 5, again, there is no spec required. 6, all right, this is also no spec. 7, they very clear mention about TWI spec, so you must refer to spec. 8, all right, this one they're talking about material, so I think this one refer to spec. 9, this one no spec. 10, this is also no spec. All right, so I repeat again, question 10, no spec required. 9, no spec. 8, yes, you refer to spec. 7, refer spec. 6, no spec. 5, no spec. 4, no spec. 3, sorry, number 3 here, you must refer to spec. 2, spec. Number 1, if you read carefully, basically, it's not required any spec, but please check from the spec too. Yeah. All right. All right. We're going to discuss from the slide here. One of your inspector informed you that batch 8018 electrode has arrived on site and required heat treatment before use. Which of the following best apply to this type of electrode? So we know that 8018 here is MMA, basic electrode. So 8018 is basic electrode. If you look at answer A, generally this type of electrode can be used directly from container with no heat treatment. But we understand basic required baking. It must be baked. Cannot use straight away from container without baking. So that's why A is a wrong statement. B, accordance with TWS, this type of electrodes are not permitted for use. Basically, it's a wrong statement. When you read from the spec, they require basic. Yeah? See, this electrode can be used providing electrode flux recycle 50-50. So this apply for SAW, not for basic electrode. So that's where the answer goes to delta. Yeah. 2, during welding, one of your inspector informed you that the fabricator recycle flux 30% new and 70% old. Is this permitted? When I look at section 8.2 of the spec. Here, storage and handling. All SAW flux shall be stored in accordance with manufacturer recommendation. SAW flux may be recycled provided the reused flux is free from all contamination, slag, meniscus, and other foreign matter. All recycled flux shall be mixed with an equal amount of new flux, 50-50. Yeah, so that statement will give us the answer of alpha. Yeah. Question 3, you are informed that approved supplier electrode cannot make delivery for 2 weeks. He asks if another manufacturer can be used. The electrodes are the same. All right, in this case, look at table 7 of the spec. All right, in table 7 under welding procedure, all right, WPS. They're talking about approved supplier or manufacturer. Yeah? Change manufacturer or supplier. I think change your manufacturer, that's the best here. So in WPS, it said filamentary type, any change from street name and classification. So this will affect essential variables. So meaning they are not allowed, right? So that's why the answer for number 3 is A. No, electrode must be from original manufacturer, yeah, which is stated in WPS. Number 4, in large batch of MAC wires arrive on site, one of your inspector informed you that copper coating of some of the wires has been damaged during transportation. What purpose of copper coating? So this is very straightforward questions. We have go through from the handout. So the copper aids electrical pickup and protect wire from corrosion. Number 5, this one what we have discussed from the course note. So the question asks a batch of E46-3-1NIB electrodes arrived. One of your inspector asks, what is minimum yield? So we understand when we have 46 here, meaning is 460 Newton millimeter square minimum yield. Okay, so that's why the answer goes to C. Okay. Number 6, you notice a batch of cellulose electrode in welding consumable store. Which of the following statement correct for this type of electrode? I think these questions not require any spec, but sometimes you may read the spec in order to give you an idea. But I think this one we can straight away discuss from without using spec. So cellulose electrode, we understand they got high hydrogen, very high hydrogen. Then the good thing about having high hydrogen here, fast travel. Without lack of fusion, right? Because it's got high penetration. And normally fast travel here, we may refer to like a PG position. PG is vertical down, very fast travel. Yeah? So if you look at A, say this electrode can be used to control hydrogen level below 15. This is wrong statement. Because cellulose got in 80 to 90 milliliter. Yeah? B, this electrode should be big. This is the wrong statement. All right? So the best goes to C. This type of electrode are specially suited to the PG welding position. So normally we apply in pipeline. All right? 7, during your morning inspection, you notice certain electrodes being baked in their original container. Correctly fully control baking oven. In accordance with TWI spec, is it correct practice? Original container, meaning this storekeeper take the box together with the electrode inside the box. Electrode together with the box, put inside oven. So that is what the question asks. Okay, so look at 8.2 of the spec. So here it says all MMA welding consumables shall be treated in accordance with manufacturer detail recommendation when it's necessary to dry and bake the consumable. Consumable shall be removed from its original container prior to any applicable of it. So you must open the box, take out the electrode, and put the oven. So that's what is said here. So that's why the equations here goes to delta. Okay? 8. Quench and temper section is being welded with rutile electrode. Rutile electrode got hydrogen level between 20 to 30 milliliter. It has been proven that hydrogen cracking does not occur. Which of the following statement is true? All right, look at 16.2. Here, and quench temper, specific welding detail quench temper steel. All welding operation shall be conducted using welding process of welding consumable capable of depositing hydrogen level less than 10 milliliter of hydrogen, which is in scale B. If MMA welding process being used, the full welding operation, the use of basic or low hydrogen electrode only may be considered. So meaning that they not allow any cellulose, any rutile. Yeah? So that is very clear statement. Then the best answer goes to B. Basic electrode must be used. Okay? Number 9, one of your inspector answered the toughness value of electrode. So we understand when we refer to toughness value, means it's referred to number 3. So that is the toughness value. All right. 50 is the yield. All right. Yield strength value. Yeah? So the answer goes to C. This is very straightforward question. All right, number 10, tungsten electrodes are considered non-consumable, therefore it's crucial that they are used correctly. Which of the following statements is correct concerning tungsten electrode? All right, guys, so this is the slide from 3.1 talking about the tungsten type. So this one is W is tungsten. So we have a pure tungsten here. This one is thorium, cerium, lanthanum, zirconium. You see here it says used for AC. Zirconium used for AC. Okay? All right. So the answer goes to B. Sorry. So the answer goes to B. Zirconated electrodes are used on AC as they can withstand more heat on positive cycle. All right?